Okay. This lecture is going to be about acceleration. It's our final part of the lesson in regards to our one-dimensional motion. Um, and so let's define that first. Acceleration is a vector quantity that is defined as the rate at which an object changes its velocity. An object is accelerating if it is changing its velocity. Okay, so you may hear people talk about saying that someone is accelerating if they have great acceleration if they're moving fast, but it's not really doesn't really have anything to do with moving fast. It has to do with how quickly they're changing their velocity. And so I've got an animation here that I want to show you guys, and I want you to tell me what is accelerating. Okay, so we have these three cars here, and one of the three cars is accelerating, and the other two is not. So if you notice that the red car and the green car, although the red car starts out faster, okay, the blue car is actually even the last one to get going, but because it's accelerating, its velocity is increasing the entire time, so it eventually even catches up to the red car and is going faster than the red car. Okay, and so that is the basic idea of acceleration. Another thing of acceleration is, let's say you're in your car, okay, and we can feel acceleration. Okay, when we are accelerating, we are pushed against the back of the seat of the car, or pushed into the side of the car if we're turning. And we will get more into that when we deal with forces, but that's the idea of acceleration, is that we can actually feel it when we're moving. When that feeling doesn't change, okay, we have what is called a constant. We have a constant acceleration. And our constant acceleration is a situation where the rate of change, or the how fast our velocity is increasing, doesn't change. So we change by the same amount every second. So I've got another picture for you guys that will hopefully demonstrate what we're talking about here. Okay, if you look at this, we've got okay, so if you look at this, we've got a time and a velocity chart where in the first column, where you have at time 0 you have a 0 velocity, and at the first second you have a velocity of 4 meters per second. And in the second second, it's 8, and in the third, it's 12. And so that is a constant acceleration, that every single second, you're increasing by the same amount of velocity. Where in the other chart, the one on the right-hand side, after the first second, you're traveling 1 meter per second, and after 2 seconds, you're traveling 4 meters per second. And then after 3 seconds, it's down to 5, and then 4, it's to 7. And so what you're looking for is actually the differences between those amounts. And so if every second the difference in the velocity changes, then you do not have a constant acceleration. You have a non-constant acceleration. And it's a lot harder to deal with that mathematically. We will not be doing a whole lot of non-constant acceleration in here. We will mainly be dealing with constant accelerations in here. In fact, one of the most common ones that we're going to deal with is called free fall. Okay, so a constant acceleration is when we have, and it's underlined, so that's one of our vocab words. A constant acceleration is when the velocity changes by the same amount every second. where the velocity changes by the same amount every second. Okay, and one of the most common ones is called free fall. Okay, and this is what skydivers experience, and this is what satellites experience, and this is what anything under the gravity, under the power of the gravity of Earth, experience when they are allowed to just fall towards the ground. This is called free fall. Okay? And the value of this is, so like in the first second, after the first second, you're going to have a velocity of 5 meters per second. So our velocity for the first second is going to be 5 meters per second. And our velocity after the second is going to be 15 meters per second. Okay, or actually these are our average velocities. Average velocity, and our average velocity after 3 seconds is going to be 25 meters per second, and so on. Okay, well, what actually happens is that after that 1 second, we start. Well, we'll get into that later, and we'll get into that with our work. Or another way to look at it is summarized here. So we have in our first time interval from 0 to 1 second, our velocity change is 0 to about 10 meters per second. Okay, and so the average velocity, which is the velocity that we finish at minus the velocity we start at divided by 2, is 15 meters per second. Okay, and then we have, right, so this is our average velocity during the intervals, right? And so for the next second, we start at 10 and we finish at 20, and so that's an average of 15. And then for, you know, we for the third second, we start at 20 and finish at 30, so that's an average of 25, and so on. But if you also look at the distance traveled, the distance during each interval starts to increase. Okay, not to mention the total distance traveled starts to increase even greater, and it actually increases exponentially. It increases with the square of the time, and we'll get to that a little bit later. But that is the effect of a falling object. This is the data that shows the effect of a falling object. Okay, now the way we can calculate our average acceleration. So calculating okay, so if we're going to calculate our average acceleration, our average, which is acceleration with a bar over it, is how I will write it. It equals, it's our change in our velocity over a change over the total time that happens. But anytime you see this delta right here, anytime you see a delta, this triangle involved in our math, it means our final situation minus our initial situation. So this is going to be our final velocity minus our initial velocity divided by the total time it takes. So let's say we're in free fall, and going from the data that we had above, okay, that our final velocity after 4 seconds was going to be 40 meters per second. But our initial velocity, if we start at time 0, was going to be 0 meters per second. And that gives us the total time, and we divide by the total time it took to do that, which was 4 seconds. And so 40 minus 0 is 40 divided by 4, and that gives us an average acceleration of about 10 meters per second, which we can also write as 10 meters per second squared. And this is the average acceleration when we experience free fall close to Earth. Now, there's a whole bunch of different kinds of acceleration values, but the two that we will use primarily in here are, so acceleration, the units for it are meters per second, or meters per second squared. And I like introducing it like this, meters per second, because this is our change in our velocity for every second. We're increasing or decreasing by this many meters per second every second. This will eventually turn into meters per second squared, just to write it easily in these 2 seconds essentially multiply into each other. The units multiply to give us seconds squared. But there are other versions of it. Kilometers per hour, miles per hour per second. So it's like if you're looking at how your speedometer is changing on your car, okay, and it's how fast that dial is going, it's how many miles per hour per second. Okay, which brings us to the difference between positive and negative acceleration. So in this class, we're going to establish that on our graph that up will always be positive for us and down will be negative, and that to the right will be positive and to the left will be negative. And this is just to keep us consistent. This is to keep us consistent with our math classes. Okay, these can change. For example, if you were to look behind all of this, okay, so let's say you were on the other side of the screen here, and let's see here. Can I do this? Yeah, let's say we're on the other side of the screen, and then all of a sudden we could do this. And so this would be our positive, and this would be our negative, and up would be positive, and this would be negative. Then if you stand on your head, it would look like this, where down is, where this direction is negative, this direction is positive, based on if you do it according to your body position. So we can choose whichever graph we want. Okay, but in this class, we're going to take up as positive and to the right as positive. Which brings a couple things. Let's say that we have something traveling, and Now, let me do this again. We have something traveling from left to right, and it starts to move like that. With the speed of that, with the speed of that line, we could tell that it was accelerating because it started slow and it got faster. Well, what if we're still traveling in the same direction and we start fast, and then we end up slow? Well, what is the direction of our acceleration? Because our velocity, that's ugly. Our velocity was in that direction, okay, which was positive. But we started slowing down, which meant that our velocity was decreasing. It was going less positive. So that would mean that our acceleration, even though our velocity was positive, our acceleration, okay, so the acceleration vector was negative, which really meant it was in the negative direction. It was actually decreasing when our velocity was increasing. And so we have 2 different kinds of acceleration. We have a positive acceleration, okay, and this is generally, a way to think of this, is generally a positive acceleration is when when an object is speeding up. Okay, which would mean that our negative acceleration, which is another vocab word, negative acceleration, is when the object is slowing down. So with positive acceleration, the object is speeding up. Negative acceleration, the object is slowing down. However, this is not strict, and so I want to give you guys a chart here. And so we're going to do... I don't want to do that in green. I want to do this in white. So we're going to have our acceleration distance. Okay, and we're going to have our positive acceleration and negative acceleration. And over here we're going to have our velocity, which is going to have a positive velocity and a negative velocity. And so if we're traveling in the positive direction, if our velocity is positive, but our acceleration is positive, that means we're going to increase our speed. And I want to make sure we call this speed here. Increase our speed. Okay. Now, if we're traveling in a positive direction, but we have a negative acceleration, those are opposite to each other. They're acting against each other, so we would actually have a decreasing speed, or we're slowing down. If we're traveling in the negative direction, but we have a positive velocity, traveling negative direction, which means we have negative velocity, but we have a positive acceleration, something pushing us forward, that is also going to slow us down, because our speed would have been to the left here, but our acceleration would be to the right. And then if we're traveling in the negative direction and we are accelerating also in the negative direction, that is going to increase our speed because those are pointing in the same direction. Okay, so roughly, a positive acceleration is where we increase our speed, and a negative acceleration is where we decrease our speed. But I don't quite want you to put it like that. Positive and negative are the directions are to the left or to the right. But know that if your acceleration and our velocity are working counter to each other, like in this one here and this one here, if they're working opposite to each other, then we're going to have a decrease in speed. But if we have if we have our acceleration and velocity working with each other, then we have an increase in our speed. Okay, and that's about it for acceleration. You guys should have enough information to complete your work. And we will see you next time.